What is the OSI model? The OSI model, Open Systems Interconnection Model, is a conceptual framework used to understand and standardize the functions of a communication system or network. It breaks down the process of data transmission into 7 distinct layers, each responsible for specific tasks in the communication process. This helps ensure that different systems and devices can communicate with each other effectively, regardless of their underlying technologies or manufacturers. The 7 layers of the OSI model, from the top layer, closest to the user, to the bottom layer, closest to the physical hardware, are 1. Application layer, layer 7. 1. Function, this is the top layer, closest to the end user. 1. It interacts directly with software applications to provide network services like email, file transfer, and web browsing. 2. Examples: HTTP, web browsing, FTP, file transfer, SMTP, email, DNS, domain name resolution. 2. Presentation layer, layer 6. 1. Function, this layer ensures that the data is in a usable format and is properly encoded or encrypted before being sent over the network. 1. It acts as a translator between the application and lower layers. 2. Examples: data encryption, compression, translation, for example, ASCII to EBCDIC encoding, SSL/TLS, encryption. 3. Session layer, layer 5. 1. Function, this layer manages sessions or connections between devices. 1. It is responsible for establishing, maintaining, and terminating communication sessions. 2. Examples: NetBIOS, RPC, remote procedure calls, PPTP, VPN connection. 4. Transport layer, layer 4. 1. Function, the transport layer ensures reliable data transfer between two devices. 1. It handles error detection, flow control, and data integrity during transmission. 1. It also breaks large messages into smaller packets. 2. Examples: TCP, Transmission Control Protocol, UDP, User Datagram Protocol, port numbers. 5. Network layer, layer 3. 1. Function, this layer is responsible for routing data packets across networks. 1. It determines the best path for data to travel and handles logical addressing, IP addresses. 2. Examples: IP, Internet Protocol, routers, ICMP, ping, subnetting. 6. Data link layer, layer 2. 1. Function, the data link layer is responsible for establishing a reliable link between two directly connected devices. 1. It handles error correction, framing, and flow control over the physical connection. 2. Examples: Ethernet, MAC addresses, switches, ARP, Address Resolution Protocol. 7. Physical layer, layer 1. 1. Function, the physical layer defines the physical hardware involved in data transmission. 1. It is responsible for the transmission and reception of raw bit streams over physical media like cables, fiber optics, or wireless signals. 2. Examples: Ethernet cables, fiber optics, radio frequencies, network interfaces. Why is the OSI model important? The OSI model is fundamental in the world of networking and telecommunications for several reasons. 1. Standardization and interoperability. The OSI model provides a universal set of guidelines that ensure that devices from different manufacturers and with different technologies can communicate with each other. It promotes interoperability by defining clear responsibilities for each layer of communication. 2. Troubleshooting. The OSI model helps network engineers and technicians diagnose and troubleshoot network issues by breaking down complex communication processes into manageable layers. If a problem arises, you can isolate it to a specific layer and address the issue more effectively. For example, if data is being corrupted during transmission, you can check the transport layer, layer 4, or if the issue is with device connections, you might examine the physical layer, layer 1. 3. Modular approach. By separating functions into different layers, the OSI model provides a modular approach to networking. This allows each layer to be updated, improved, or replaced independently without disrupting the entire system. For instance, upgrading to a new encryption method at the presentation layer, layer 6, won't affect the transport or physical layers. 4. Network design. The OSI model helps in the design and planning of network architecture. Network architects and engineers can use the model to structure networks in a way that ensures scalability, security, and efficiency, allowing them to make decisions about hardware, protocols, and communication strategies. 5. Understanding protocols. The OSI model serves as a foundation for understanding the role of various network protocols. For example, knowing that TCP operates at layer 4, transport layer, and HTTP operates at layer 7, application layer, helps professionals design and manage networks effectively. 6. Education and communication. The OSI model is an essential teaching tool in the world of networking. It provides a clear, structured way to explain how networks function and how various technologies interact. It also serves as a common language for professionals when discussing networking concepts, making communication easier across teams or companies. So summary is, the OSI model is a conceptual framework that divides network communication into 7 layers, each responsible for specific tasks, ensuring that different devices can communicate smoothly. It is important because it standardizes networking processes, simplifies troubleshooting, helps in network design, and serves as a teaching tool to understand how networks and protocols work.